Okay, the question number one, we need to simplify these expressions. We got cotangent of the angle times secant of the angle times sine of the angle. The first thing I did, I changed everything on function of sine or cosine. For example, cotangent is equal to cosine over sine. Secant is equal 1 over cosine. And sine will leave like that. Nothing happened with sine. Now we got cosine at the top, and cancel cosine at the bottom. And sine, cancel sine at the bottom. My final answer will be 1. Okay, we only simplify. Second question for the review. We got cosecant times cotangent. All is divided by secant. Similar to the previous sample, I change cosecant. Cosecant is equal 1 over sine. Time cotangent. Cotangent is equal cosine over sine. All is divided by secant. Also, secant is 1 over cosine. And now I try to simplify, put everything together. And the time we got multiplication of two fractions. Okay, we multiply across. Now we got 1 times sine. Sorry, 1 times cosine over sine times sine over 1 over cosine. Now we got complex fraction. The easy way to solve complex fraction is apply double C. Now we got cosine times cosine. And we got sine times 1. And cosine divided by sine is equal cotangent. That will be our final answer. Please, if you got question, let me know. Question number 3. Sine square of the angle plus 2 sine of the angle minus 63. The statement say factor. Okay. I assume this one is similar to a trinomial. And you get sine square, sine, sine, sine. The first sign is positive. The second sign is positive times negative. Negative. Now we need to find two numbers when you multiply 63 and when you subtract it's 9. It's 2, sorry. Now we got 9 and 2. And we stop it because they're only asking for factor. Similarly, you got this one. It is similar. And you open parentheses. Okay, it's positive and negative. 9 and 2. We stop it right here because no equality. Okay, we stop it right here. If you get equality, you have to continue. Now we get tangent of the angle, times cosecant of the angle equal cosecant of the angle. The statement for this problem says, verify the identity or prove that the left side is equal to the right side. Remember, until now, we don't know if this one is true or not. I go to the left side because it's more easy to simplify the big thing than maximize the small thing. I go to tangent. Tangent is equal sine over cosine. Cosecant is equal 1 over sine. It's equal to this part. We don't know. I simplify sine and sine. Now we got 1 over cosine. It's equal to the right side. We don't know yet. Oh, we know that 1 over cosine is equal to secant. And secant is not equal to cosecant. That means this statement is false. They are not equal, no equality. Now we got cosecant of the angle divided by cotangent minus cotangent of the angle divided by cosecant equal sine over cosine over cotangent. Sorry. I don't know if the left side is equal to the right side. When you need to prove that we got equality. Now I want to minimize the left side when you see fractions. The best way to solve fractions, in this case, I multiply these two and we apply cross multiplication. And the LCD will be cotangent times cosecant. We apply the cross multiplication, and we got cosecant square minus cotangent square. If you check the paper that I gave you in advance for the formulas, the only formula you have to remember is this one. Okay, the first Pythagorean formula for the unit circle. And I look at something that mentions cosecant and cotangents. We got two options. If I divide it by cosine, sorry, by sine, we got one. We got cotangent, and we got cosecant. If I remove the cotangent to the right side, on this part will be exactly this part. That is equal 1. And we got 1 over cotangent we got cosecant equal to this side. We don't know yet. But if I analyze this part, only this part, 1 over cosecant is equal sine, because the reciprocal for sine, the reciprocal for sine is cosecant. Now we know in the top, we got sine of the angle, and the bottom we got cotangent is equal to this part. We say it's true. We prove that the left side is equal to the right side. Okay, the statement says find all angles. All angles in the way. Well, the statement they never mention between who and who. We assume will be only in the unit circle. And we know that the unit circle is something like that. We talk about sine, and we have to work in the y-axis because sine is that relationship with the y-axis. And this point will be 0, 1. And this point will be 0, -1. The angle is equal. I need to look for the inverse for -1. If I use the calculator, they go straight to the answer, but without calculator, I go to the unit circle. They never mention if they want the answer in degree or pi. No problem. You got 0 degree, 90 degree, 180 degree, 270 degree, and again, 360 degree. In this moment, they are coterminals. So since sine represent the y-axis, when sine is equal -1, exactly in 270 degrees. Exactly right. If the question mentioned that they want the answer in pi, this one will be 0, pi over 2, pi, 3 pi over 2, and this 0 will be equivalent to 2 pi. Now the answer will be 3 pi over 2. Remember that traditionally, I go in this direction, positive. Or some of the students like to go in this direction. If you go in this direction, this one will be -90 or -3 pi over 2. Sorry, -pi over 2. Because you change the direction. Also, this answer is valid. But remember that the finest multiple choice, traditionally they go to the positive direction. Please, if you got questions, let me know. In this statement, they mention zero included to 360 degree open. Okay, in the unit circle, you start right here in 0 included, and you finish right here, or you continue because open. Okay, you're allowed to go many times. How many times? We don't know, because they don't mention how many times. We can go n times or n revolutions. Now the best way is do the inverse. Negative radical 3 over 2. Close the parentheses. Remember the short table for sine, cosine. Square root. One student sent me an email asking why I don't make the square root for the first one, because the square root for one is one. That's why I didn't make the square root for the first one. Also for the last one, the square root for one is one. Now I look for radical 3 over 2. But we mentioned cosine. Remember, cosine will be the x-axis. When cosine is equal radical 3 over 2, exactly in this intersection.
Professor.
Yes.
Yeah, you can also use the triangle
Yeah,
to
you
show
can,
them
you can use a triangle.
just like the one bunny, two bunny, three bunnies on a cage. I don't know if you remember that.
You can use this triangle you want. And this one is 90. This one is 60 and 30.
Yeah.
Okay, now you got 1,
Two.
2, square root
Yeah.
3.
Yeah.
How I remember 1, 2, 3. And the last one radical. So if you got the table, it's easy to control the table. 1, 2, 3, 1, 2, 3 divided by 2 and radical.
Yeah, and there's another. Then I also show them the other one for the 45 degrees. It's very easy. It's easier than this one.
Yeah, but you don't need 45 degrees right here.
No, I'm just saying like for them to think about it, for them to remember.
Yes. For the 45 degree, you got the perfect square, something like that. This one is 1, 1, and this one, 1, 1, radical 2. And this one is 45 degree, 45 degree, and 90. You can find all the identity that you want, right? Now also included right here in the second column.
Also, and to remember the guys that we cannot have radical at the bottom. That's why the radical disappears for the 45 in the bottom.
It's a
And then we
rule
put it in the top.
it's a rule that you have to remember for Math 150.
Yeah.
Yeah.
I forgot the name, Professor, but
Yeah, they call rationalization. Rationalization.
rationalization. There you go. That's the one.
Okay, you can compare with immigration. You are illegal in the bottom, you have to fix your paper. Now, when cosine is equal radical 3 over 2, remember that this table told me, also the triangle told me, all answer positive because we talk about the first quadrant. But in the equation, they say minus. When cosine is minus, exactly right. This one will be radical 3 over 2. Now we got one answer right here and another answer right here. When you're looking for the unit circle, you're going to find maybe one answer, maybe two. In the calculator, only mention one answer, but in the unit circle, we find two answers. Now, what I know that this one is 180 degrees. And the angle that you find is 30. If you go in this direction, you say 180 minus 30 will be 150. If you're in this direction, you add 180 plus 30. You need 2/10. Now, in this moment, we got two answers. The first answer will be 150 degrees. Or remember that they mention n times because the last point is open. Plus, how many revolutions? We don't know. 360 degrees. The second answer will be 2/10. Okay, 2/10. And again, they never stop it because that's open plus n 360. If they're asking only one revolution, you say 0. It will be only 150 and 2/10. You try to use the calculator, they give you only one answer. Because the calculator working in the first quadrant. Okay, question number 8. Say cosine square of the angle plus 2 times cosine of the angle plus 1 equals 0. And the statement says find all real numbers in the interval from 0 to 2 pi. And again, the term is open. They never mention degree, they mention in pi. In other words, we have to read the answer in pi. The first step, I factor. In this case, equals 0. You got cosine, cosine. If you multiply the two, you got cosine squared. The first sign is positive, and the second sign will be positive also. 1 and 1. In other words, we got only one answer. Sorry, only one option. I try to solve this equation. And the angle will be the inverse when it's -1. We go to the unit circle. We talk about cosine. Okay, cosine. I'm going to use the x-axis. And we know this point will be 1, 0. And this point is -1, 0. And they're asking, when you find the inverse, when cosine is equal to -1, exactly right here in 180 degrees. But my question say pi. I need to mention pi. So the answer, the only answer will be pi. But what happened? They mention in the statement the 2 pi is open. Now we have to mention plus n. In the previous one, I said 360 degrees. In this one, I mentioned the revolution that is 2 pi. My first answer will be pi. If they're asking for more answer, I have to say plus n 2 pi. I mean, my first answer is right here. My second answer, 1 revolution. The next answer, another revolution, and another revolution, and another revolution. Forever. Okay, the question number 10, I know some students they complicate life right here. Sorry, question number 9. The only information that we have is A is equal 34, B is equal 69, and the angle is equal 74 degrees. And they're asking, determine the number of triangles with the given parts. I mean, short remark right here. If somebody mentioned right triangle, I think in this triangle. Okay. A, B, C. If somebody mentioned right triangle. When this one, they never mention right triangle. I assume it's an oblique triangle or no right triangle. And will be A, B, C. And this one will be alpha. $74, yeah, 69, and we got 34. And the question is determine the number of triangles. Apparently, we got one triangle, but we don't know if fake or not. In order to check if the triangle is fake, I need to find an imaginary edge. Okay. And we say sine of 74 degrees is equal to the opposite, that's h, and the hypotenuse is 69. And we got 69 times sine of 74 degrees equal h. My calculator said that h is equal 66.33. Now I look for my notes, and we got the case number 1. And they mention if the A is less than h, this triangle is zero triangle because this triangle is fake. Now, the A is 34, is less than 66.33. Yes, zero triangle. This triangle is fake. The truth of this triangle will be something like that. I mean, this one, what happened with this part? We don't know. I mean, it's fake. This angle doesn't exist. How many triangle? Zero triangle. Why? It's fake. Some people use the law for sine. We can use the law for sine, you want. The law for sine say sine of 74 degrees over the opposite, that will be 34. And the sine for this angle that we don't know. Since the opposite for small b will be capital B over 69. 69 times sine of 74 degrees divided by 34 will be sine of capital B. Seeing I'm looking for B, capital B, I need to apply inverse. Now sine inverse 69 times sine of 74 over 34. The calculator said that this one is equal 1.95 will be the angle. Now be careful of this part because the unit circle, the minimum point is -1 and the maximum point is +1. Meaning that 1.95 is outside the unit circle. And the reason that this angle is undefined, doesn't exist. This one doesn't exist. You got two options. You can use the test using the age or try to find using the lawful side, the angle that's missing. And the PowerPoint got better explanation than this one. Question 10. We got B is equal to 31.7. We got a small b for 13.12. And we got the small 8 is 24 plane. Seeing the never mentioned this triangle is a right triangle, I think it is one. Maybe this one is A. This one is B. This one is alpha that we don't know, but we know this one. Beta that is equal 31.7 degrees. The statement says solve the triangle. If you find more triangles, you have to give you the both solutions. Okay, I want to know how many triangles we have in this triangle. I know it exists because they say solve the triangle. If they say solve the triangle because they know that this triangle is true. Okay, we got the age. I'm gonna say sine of 31.7 degrees is equal to the opposite is age over 24. 24 times sine of 31.7 degrees will be h. Okay, my answer will be 12.61 is h. Okay, now I check the cases. The case number 1 told me if the A is less than H, we got 0 triangle. Let me see, the A is 24. All right. It's less than H, and the H is 12. It's false. I mean, this case, you have to fail this case. We don't need this case because the A is bigger than H. That means the triangle exists. I go to the second case. I mentioned that if A is equal to B, or A is bigger than B, you got one triangle. Sorry, H. If you compare the A and the H, they are not equal. This part doesn't work. For the second part, for the case 2, say that if A is bigger than B, the triangle exists. That means we got only one triangle. We have to solve the triangle only one time. Only one time. I need to find this angle. We know this one already. We know this side. And we know this side. Since you know only this side, it's easy, since you got these two, this side and the angle, we got the sine and this angle is missing, it's possible to find alpha. Now we say sine of alpha, and the opposite 24, sine of 31.7 degree over 13.12. Sine of the angle will be the multiplication for these two divided by 13.12. Now sine of the angle will be, according to my calculator, 0.96. And look for the angle. The angle, I use the inverse. Since this number inside the parenthesis is less than 1, it's possible to find the answer. Use the calculator. The inverse 0.96 will be 73.73. Degree. Now, how you find this angle? Now maybe we can say this one is this C. We know already that all triangle is 180 degree. Minus 31.7 minus 73.73. Minus 31.7 minus 73.73. The new angle will be 74.57. This one, 74.57. We got the three angles because we know already alpha is equal 73.73 capital B, that is 31.7. We know the C, that is 74.57. We know the side A, that's 24. We know B, that's 13.12. C is missing. Okay, this one is C. I use the law for sine again. Sine 74.57. And the opposite is C. Sine 31.7 over 13.12. And we need to solve for C. Can we apply the proportion? And we got 13.12 times sine 71.57 divided by sine 31.7. And the value for C will be 23.69, almost 24. You solve the triangle because you got the three angles. Also, you got the three sides. You find an extra side, something is wrong. It's the only information that we have, and they're asking, find the area for this triangle. If you got a right triangle, you say the area is equal 1/2 base and altitude. Because the one is a right triangle. So, and this one they never mention is a right triangle. I mean, the triangle is like that. Capital, capital, and capital. If you want to know the area using the capital A, using the capital A, or using the capital B, or using the capital C, if I start the capital A, I said the area will be 1/2 B times C times sine of capital A. If I want to start right here, What happens if you want to start in B? I say half, and you the two adjacent angles, and the opposite for this one is B, with sine of B. This formula is in the paper that is in the unit. They say formulas. If I want to start right here, say half AB sine of capital C. Let me see what happened this one. The information that we have. You know this one, 48.3. I don't know this one. A is not given, but we know B. And we know C. And they're asking only for the area. That will be half. I'm going to use this information. Will be 87, 12.7 sine of this angle, the information that we have. If I use a calculator. If you know this angle, if we know this angle, I use the adjacents. I have in this one, we got A. See A, I use the adjacent BC. When you're looking for B, I use the adjacent AC. When you're looking for C, I use the adjacent AB. The question 12. We know this information. We know this one. And we know this one. They mentioned this one is alpha. They mentioned this one is beta. And they mentioned this. And this one, if I try to use the law for sine, we got one unknown, one unknown. Also another unknown. No matter how combination you use, you got unknown. That means doesn't work using the law for sine. We got another option, the law for cosine. If you know the adjacents and this angle, similar to the previous one, I can use the law for cosine because my unknown will be the opposite. And C squared is equal A squared plus B squared minus 2 times AB cosine for the capital C. Which one is C squared? We don't know. So I know this one is A because opposite to alpha. And we know this one is B because opposite of beta. Two times 8 times 8.46. Cosine. What is the opposite for the small c? 109. 109.2. We need a calculator. We see that c squared is equal to 180.09. Apply the square root. We got 13.42. I find already C, but we got two angles that's missing. And we know this one is equal 13.42. We got two angles that's missing. Maybe I decide to find alpha. It's no rule, or I decide to find alpha. I say sine of alpha. And the opposite will be 8. Sine 109.2. And the opposite 13.42. Apply the proportion. Apply the calculator, and my answer will be 0.563. Now alpha will be the inverse for that. Will be 34.27 degree. Now I check what I have. We know the angle alpha is 34.27. We know beta, no, or we know the capital C, that is equal to 109.2 degree. We know A, that is equal to 8. We know B, that is equal to 8.46. And we know C, 13.42. Only the beta is missing, but we know that inside the triangle is 180. We subtract 109. We subtract 34.27. My answer will be 36.53. And you complete the triangle. Okay, question 13. They say complete the triangle. Okay, in this one, it's easy to find this angle. Because again, we got 180 minus 26 minus 51. It will be 103. 103. Now, what is missing? A and B. Okay. If I choose to find A, we say that sine of 26 over 8 sine 103 over 28. Apply the proportions. We multiply 28 times sine 26, and we divide it by 103. Okay. Now, what is missing? B. If this one was a right triangle, we apply Pythagoras, but no right triangle, no Pythagoras. And again, if you're looking for B, we got sine of 51 over B, sine 103, 28. Apply the proportions. Will be B. Okay, note that we don't have to find the inverse because we're looking for size, not for angles. It will be 22.33. They're asking for this angle that we got already. We know alpha. We know beta. We know small b, small a, and c. And you complete the triangle. And the last questions. We know the triangles like that. A, B, and C. And they're asking for the area. It's impossible to apply the law of cosine for area. But we know another formula that also is in the paper that's given in this unit. They call the Aaron formula. The Aaron formula says the area is equal to the square root. We got the capital S, that is semicircle minus the area, minus the side A, the semicircle minus the B, and semicircle minus C. How you find the semicircle? You say A plus B plus C divided by 2. It's the reason they say semi. We divided by 2. Okay. Look for the semicircle. This way will be 8.5 plus 16.2 plus 15.4 divided by 2. Eight point five, 16.2, 15.4 divided by 2. $20.05. Now we're applying this formula. 20.05 times 20.05 minus 8.5 minus minus will be the square root of 4145.9. This is square root 4145.9. 64.39 will be the area. Questions?